Alright, before I start this exercise, is using matrices with transformations. So we have talked about three types of questions. So you can have three pieces of information in the transformation question: original equation, resultant function, and the transformation description. And also I have mentioned at the very beginning of this topic, I said matrix will be equivalent to a word description. So if I give you the matrix or give you the word description, what you can actually have. Let's write this at the beginning. So transformation description equivalent to matrix. Like this matrix, we call that T, transformation matrix, and that is equivalent to x dash equals to x dash, it's just not a good spot to write, x dash equals to sum x, and y dash equals to sum y. Okay, those three things are exactly the same. Give you anyone, like for example, give you the matrix, you should be able to write x dash equals to sum x, y dash equals to sum y, or give you the x dash equals to sum x, y dash equals to sum y, you should be able to give the word description, like what we already know how to describe it, and also you need to give the matrix as well. You can also give the matrix as well. I'll talk about how to convert between that, but I just want to say at the beginning, you can achieve that. Okay, that's what we're basically doing. You need to have both of that at the same time. Okay, so, well, math is represented by numbers, letters, and symbols. So we don't use the sentence that much. So when we talk about the description, we say a dilation by a factor of what, that reflect by which axis. It's a long sentence. So I want to really reduce that by a mathematics expression. So that's we introduce the matrix. So by looking at a particular matrix, you know that what that represents. For example, if there's a dilation, well, let's think about the reflection. Reflection is easy to think about. Translation matrix by reflection. So produce a reflection in the y-axis. So what you can write will be x dash equals to minus x, y dash equals to y. So you have a negative of the original x and then same as the original y. Therefore, the matrix will got negative 1 here and 1 here. So all the transformation matrices represent, well, dilation or reflection will represent about 2 times 2 matrix. So this spot will be the x spot. This spot will be the y spot. Okay, x spot, x spot. No, that's the y spot. Okay, so for the x spot, you will have a negative 1 because the original x, new x will equal to negative of the old x. You know, like the matrix we learn the linear, solve linear equations, we write coefficient only. So the coefficient will be negative 1. And for the y value, the coefficient will still be 1. But the other two boxes will be 0, 0. Okay, the other two will be 0, 0. Well, similarly, if you produces a reflection in the x-axis, then the y place will be negative 1, like you are negative the y. Most of the time, this diagonal will be 0, 0. Okay, most of the time that will be 0, 0. There will be a case where it's not 0, 0. I'll show you in a minute. And the third one says a reflection in both x and y. So 2 of that negative 1, like negative x dash, negative x, and negative y. So both negative. Okay. This one, okay, those 2 at the bottom are the special one. We don't really use the last one, okay? I never see question related to the last one. You can just ignore that one. That's maybe just like I want to add it. But like produce a reflection in the line y equals to x is possible to be asked. Produce a reflection in the line y equals to x. Have a think. What kind of graph is that? If you have an original graph, you reflect that in the line y equals to x. What's that graph called? Inverse. So you're going to have an inverse if you do that. This will be represented by this matrix. Let's have a think about this matrix. Originally, the 2 spot for 0 should be 1, 1. Now, like, it means like the original x disappeared and become a new y value. Okay, so the x disappeared but become a y, and this means like it become an x but the original y disappeared. So x dash become y, y dash becomes x. Okay, you swap the x, y values. You swapping the x and y values. So that's how this matrix represent. Normally it will be this diagonal to be 0, but this time is the other diagonal to be 0. You don't need to understand why that happens. It's just like when you times it, you can see why the matrix should write in that way, but you can just remember it. So my way of remembering is like the original x disappear, becomes 0, but accordingly the y will increase by 1, so you have 1 y value. So is x dash equals to y and y dash equals to x. That's how you swap the x and y. That's how you swap the x and y. So you need this matrix to represent that. Okay, so let's come back to see the dilation. If I say there's a dilation of n from the y-axis, it's changing the x. So your x will become n of the original x, so that become an n. Produce a dilation of a from the x-axis is changing the y value, so there will be an a here. So you keep original like x. X is 1, still 1x, but the y become ay. If you dilate from both axis and y-axis, so the x-axis, so from the y-axis you will have n, that's changing the x, and dilation of a from the x-axis, which is changing the y, that's put this spot. So this basically is the dilation factors and reflection factors. Is the -1 or like any positive dilation factors you put in the red spot. Okay, what these matrix used for, why we need those matrix, like how we can use for it. Let's write another equation at the very beginning. Okay, x dash equals to t times x. T is the transformation matrix, and okay, just get it further. What is x dash? X dash is x dash y dash. That's the new point. New point equals to what? New point equals to the transformation matrix, which is the 2 times 2 matrix, times with what is x? X is xy. That's the old point. So the old point times with the transformation matrix, that should give you the new point. Okay, the old point times the transformation matrix, that will give you the new point. X dash is x dash y dash. X is xy. And also, we normally don't write x dash y dash as that. We write, okay, x dash y dash, we'll use this notation to represent that. When you see this notation, that means x dash y dash. That's the xy under the transformation t, which means that's the new point. Okay, that's the xy under the transformation, but that means the new point. So when you see t bracket xy, that means x dash y dash. Okay, that means x dash y dash. All right. Okay, let's have a look. Okay, I will talk about that when I reach that point. Okay, the last one is like the translation. When you move to the left or to the right, that's the translation. So the translation will represent by a 2 times 1 matrix. So let's say if I said like translate 2 to the right and translate 3 down, then the translation matrix will be 2 to the right and -3. So it will be with the sign. Okay, moving down or moving to the left, that's negative. Moving to the left or moving down, that will be the negative. So you will add that. You will add that at the correct place. So you know, like we have x dash equals to t times x, and then you will add this one. Let's say that's a matrix A. So you will add the matrix at the back. Okay, you add, or you can add into the front. Doesn't matter. But also it depends on when the translation happened first, whether the translation happened first or whether it's the dilation happened first. If it's the translation happened first, you will bracket that. Okay, you will bracket that. If the translation happened first, you bracket that and then times the dilation. Again, it's the same as before. The transformation order must be the same as the calculation order. So even calculate matrix, that will be the same as calculating matrix. So if you translate first, it needs to be in the bracket and then times the matrix in the front. Okay, matrix must, like the transformation matrix must be times in the front, not after. Not after. You can't times it after. Why you can't times it after? That's a 2 times 1 matrix, and we have a 2 times 2 matrix times at the back. It's not going to work. Okay, you can't times those two. So the transformation matrix must go to the front, okay, not at the back. Okay, let's have a look at example 1. Let's have a look at example 1. Find the image of the point 2, 3 and a reflection in the x-axis. Okay, in the x-axis. Well, I can tell immediately that point will become 2, negative 3, right? But like how we can do this by the matrix method. So remember, the new point equals to the transformation times the old point. So the transformation is a reflection in the x-axis is changing the y value. I will times the old point. That's the original point. Okay. Remember the calculation for that. Row times by column. That's 2 and negative 3. Okay, you achieve the same thing as you think about. So that's it's a really easy example to show you how it works. Okay, how it works. B said a dilation factor K from the y-axis. So from the y-axis is changing the x. Row times column. You can see that's 2k and 3. Well, if you know how to calculate matrix, that would be really easy, like really straightforward. The old point times with the transform matrix, and you can see what's the new point. Okay, then let's have a look at, well, as you know how it works, let's have a look at the matrix. Well, let's have a look at the, you don't need to turn back to the front page, but I just want to show you. Okay, you can see like there's always a diagonal with 0, 0. Can you see that? There's always a diagonal with 0, 0. If you look at that, that's like 0, 0. Here is the 0, 0. As what you all see here, there's a 0, 0 here. But it's not always true, because this one, like all this matrix, only talk about one thing. They only talk about one thing, like either dilation or reflection, or reflecting the line y equals to x, or like it's only happened something, one thing happened at the same time. So you use one simple matrix to represent. But if there's multiple things happening, okay, multiple things happening. For example, a reflection in the line y equals x combined with a dilation and then transfer somewhere and then dilate. There's multiple things happening. You can't really tell use by using one matrix. You can't predict what the final matrix will look like. Yes? So I can't predict it's always 0, 0 on one diagonal. Okay, this 0, 0 on one diagonal only true when there's only one thing happened. If there's multiple things happening and you combine everything together, it not necessarily looks like 0, 0 on one diagonal. Therefore, why I'm talking about that with you, because you can have a look at example 2. Example 2 says, consider a linear transformation T maps to 1, 3 to -2, -3, and then a 2, 4 is mapping to that point. So give you 2 points and tell you how, like, after some transformation it becomes a new point. I don't know what's the transformation matrix T, so I need to decide what is the transformation matrix T first. But as I said, I can't predict anything yet. So I will make A, B, C, D. Like, I don't know whether AD will be 0 or BC will be 0 or not, or like there will be 4 numbers here. I just set up a matrix in case, okay, A, B, C, D. I assume there's all values other than 0. So A, B, C, D will times with 1, 3. That's the odd point. That give you -2 and -3. Also, A, B, C, D will times with 2, 4. That will give you -3 and -11. Now I want to, well, for matrix question, 99.99% of the time, you need to expand, like, times it together, like trying to see like equivalent both sides. So I can times for 2 times 2 and 2 times 1 matrix. So I will expand that. That will be A plus 3B, and that will be C plus 3D. And you can see A plus 3B must be equals to -2. C plus 3D must be -3. Using the property, if 2 matrices wants to be the same, all the entry at the corresponding place must be the same as well. So there are 2 equivalent matrices, then they must be the same. Okay, they must be the same. Similarly, we will have on this side 2A plus 4B equals to -3. 2C plus 4D equals to -11. So we can use this equation to solve for A. We can use those 2 equations to solve for AB, and then the second 2 use for CD. I can times the first equation by 2. 2A plus 6B equals to -4. And then you have 2A plus 4B equals to -3. And you want to subtract between that. That will be 2B equals to -1. B equals to -1/2. So A equals to -2 minus 3 times -1/2. A will be -1/2 as well. So same thing here. 2C plus 6D equals to -6. 2C plus 4D equals to -11. 2D equals to 5. D equals to 5/2. Well, they are just calculations. Like, I don't want to go through that with you. You can just figure it out by yourself later. Okay, it's just like eliminations. Times the first 2 equations by 2 and then subtract between the second one and the first one. So C will equals to -3 minus 3 times D. C will be -6/2 minus 15/2. C is -21/2. So the transformation matrix is -1/2, -1/2, -21/2, 5/2. I want to find the image of the point -1 and 1. I want to find the image of -1 and 1. So I will times -1 and 1 together with the transformation matrix. Okay, to calculate this, the easiest way will be take -1/2 out from the matrix. You know, like we can times the scalar factor in, also we can get it out. So that's what we will have. -1 plus 1, that's a 0. -21 minus 5, that's -26. And then I can times that back. Is 0 and 13. So the point after the transformation will be 0 and 13. Also, just let you know, I can't tell what kind of transformation is that. This is not really some transformation we have learned before. Like, if you times it, like, there will be a mix and xy in x dash. So it's very hard to say what the transformation actually is, but that's the way of doing it. Okay, it's not asking you what is the transformation, how do you describe the transformation, but they just said there is some transformation happening, can you just represent this in the matrix and find out the transformation matrix and then find the image of 1 point. Okay, it's not very common questions in the VCAP paper, so it's never really asked in this way, but like it's a very good practice on matrix calculations and understand Tx equals to x dash. Okay, understand Tx equals to x dash. Okay, let's have a look at the next example. Okay, can you add something for me for this question? Find the image of the point 2, -3 and the reflection in the x-axis, followed by a translation of 5 units to the right, and then a dilation by a factor of k from the y-axis. Okay, just remember Tx equals to x dash. So I'm trying to find a new point. I'm just find the transformation matrix and then times with the old point. So my old point is 2, -3. Okay, that's my old point. Okay, let's have a think what's happening first. And the reflection in the x-axis is changing the y value. Okay, that will be the first new point. 1, 0, and 0, -1. Then followed by a translation of 5 units to the right. It will look like this. There's no vertical translation, so that spot is 0. And you must remember to bracket that because you plus something. Okay, the last thing is a dilation factor of k from the y-axis is changing the x. But be careful. It must be in front of the first matrix. Okay, so T1, this is the first transformation matrix. That's the T2. You can't swap the order. You can't swap the order. Okay, it must be like this. Okay, it must be like this. You can't swap it. It must be exactly in this order. All the transformation, like say if there's more than one dilation or reflection happening, you need to times them in order, but the first one must closest to the odd points, and then you write things into the front. You can't write at the back. As I said, the thing in the bracket, it will be a 2 times 1 matrix. You can't times something 2 times 2 at the back, so it's not possible. Must time things into the front. So an update version of this will be x dash equals to tn dot 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 t3 times t2 times t1 times x. So anything happen like later will be into the front. Okay, will be into the front, not after. Well, if you swap T1 and T2, the answer will be different. Okay, if you swap T1 and T2, the answer will be different. It must be like this. Okay, let's calculate that. So I will keep this one. It's not this turn to calculate. So we'll calculate this one first. So 1, 0, 0, negative 1 times with that. Don't forget the bracket. So that's a 2. That's a 2 and 0 and 0, 3. Okay, so the first after the transformation reflection in the x-axis, that changing the y, the new point becomes 2, 3. And then you move it 5 units to the right. That will be 7, 3. And it will be 7k and 3. Any questions? This question is important, especially after I add the translation in between. You must follow the particular order of writing it. You can't swap T1 and T2. If there's no reflection, that's fine. Okay, if there's no reflection, that's fine. Translation. If there's no translation, doesn't really matter if you do dilation first or do reflection first. But because of the translation, you need to get the order right. Okay, must times into the front. Okay. Next example. Express the composition of transformation dilation factor K from the y-axis. Okay, so there's a dilation factor K from the y-axis, followed by a translation defined by this. Mapping the point xy to x dash y dash as a matrix equation. Okay, let's do this first. As a matrix equation. So t times x will give you x dash. Okay, or plus c if necessary at the back. So a translation is defined like dilation factor of k from the y-axis. That will be this matrix. I will times that with the odd points, followed by a translation factor. That will give you the x dash y dash. That's the equation. Okay, we finished 1 mark. That's 1 mark. And then says, hence, find the xy in terms of x dash y dash respectively. So I want xy to be the subject. I want xy to be the subject. I'll introduce the book way first, and I'll go through my way of doing this. If you want xy to be the subject, which means you want to solve for this. Okay, you want to make xy to be the subject, you want to solve for this. Okay, for not quadratic, matrix solving, you can minus, you can add, but you can't divide. You can times the inverse, right? That's how we solve for it when we deal with the linear equation. So let's have a look. First of all, I need to subtract. It will have x dash minus a and y dash minus b. But this is not a 2 times 2 matrix. This is still a 2 times 1 matrix. X dash minus a is a number. Okay, that's a number. And then xy will equals to the inverse times the inverse into the front. Okay, again into the front, not at the back. So xy equals to 1 over k. Swap those two and negative the other two. So that will become this. So 2 rows and 1 column here. Xy equals to 1 over k. Okay, this one is just x dash minus a. Second one will be k times y dash minus b. So x equals to 1 over k, x dash minus a, y equals to y dash minus b. The k and 1 over k get cancelled. Okay, that's the book's method. They use matrix to rearrange the matrix to solve for the variable x and y. Okay, to solve for the variable x and y. Okay, this is like some question. I feel. Okay, so what matrix actually give you? Matrix will give you exactly the same thing as you write the equation x dash y dash. So let's expand this matrix. Okay, I'll copy this line again. That's the matrix we write. Okay, I will just calculate it. Okay, I just calculate that. I don't care like what is the subject, just expand and equalize the top and bottom. So what I will have here is kx and y. And plus ab equals to x dash y dash. So what I will have is kx plus a equals to x dash, y plus b equals to y dash. Yes? Can you see that's exactly what I can have from the sentence already? Right? A dilation by factor of k from the y-axis, that's kx, and then translate a units to the right, that's plus a. And there's no other dilations, and then translation of b units up, so y dash plus b. That's exactly what I'll have. Like, matrix, I feel the matrix just make question more complex. It just on purpose testing or something. Okay, so this is exactly the same as what we did before. It's just taken more complicated and ask you to do transform matrix calculation. I don't really like this idea of doing transformation matrix. Like, it's no point. It's exactly give you the same thing. Also, you need to remember all the matrix, but you need to know it. They will test it like on purpose. That's just how it will test you, how it will test that. So you need to calculate the matrix, find the inverse, and do all these calculations. But anyway, like from my point of view, for that, like even though I'm not write this line immediately, I still use the matrix. I open like times two matrix, add matrix, and then equalize the two lines is all using the matrix property. I will still have the same thing. How about just rearrange it from this point? I can just rearrange it from here. Can you see how much working like I need for this method and how much working I need for this method? This is like a really formal method to make xy to be the subject. Like it's basically not testing your transformation, it's testing you how to deal with matrix. Okay, how to do matrix calculation. I feel like if they, well, it's a good place to test you how to do the transformation matrix calculation, but there's no point for a transformation question. Okay, so it's nothing to do with the transformation itself, and except the first line. That's how you use matrix to write it out. But like basically, it's just this question is just from this line to this line. That's it. I can use two lines to finish this question here. Okay, you need to see the like. The actual meaning of this question is not, matrix is not something terrible. It's just create something to test you, and it's exactly the same as before. Okay, it's exactly the same as before. So if you can see the connection between matrix and the word description, you can find the question is very easy actually. Okay, so very easy, unless if they on purpose ask you complicated like matrix calculation, you just need to be careful on your calculation. That's it. So nothing really special for the matrix. I'll stop here today. The rest of the time, you can try the next 2 pages. Okay, I'll still go through the question with you, but like try the next 2 pages. I think all the questions you can just do it by yourself. There's nothing hard. Try it first, and then we'll discuss that tomorrow. Let me try.